I will be presenting about a physics problem called the monkey's dilemma. Now, this was given to me by my friend Arch in the master's class. Now, it's really interesting. So let's take a look at this. A monkey is climbing a rope, and on the other side of the rope is a stone, and the stone is suspended from a tree branch. Now, it could be a pulley. It doesn't have to be a tree branch. Now, if the stone and the monkey are the same mass, as the monkey climbs up the rope to try to get that fruit, what is going to happen? That's the question. Now, there's several different possibilities here. One is that as the monkey climbs, the stone will fall down, and the other is that as the monkey climbs, the stone will go up, or will the monkey climb and the stone would not move at all? And is the monkey in danger at all? I'd like you to pause the video here, and then you could think about it before I go to the next slide. Okay, I will be giving a little bit of physics explanation now. Now the physics, now we're going to make some force diagrams about each side. Now if we take a look at the monkey is suspended by a rope, and the rope has a tension, that's going to be the T2, and the monkey has a weight, which is its mass under the gravitational acceleration. On the other side, the stone is the same way. It has a tension on the rope, T1, and it also has a weight. And the tension, because it's the same rope, the tension 1 equals the tension 2, so they are the same. But in the beginning, before the climbing, the whole system is at rest, and it's only from the force of the monkey that is going to cause the system to not be in rest, and that's Newton's first law of motion. Now moving on. So what happens when the monkey starts climbing? Now, from Newton's third law of motion, which is that if you have a force, it's acting on an object, the object will act with an equal and opposite force on it. So here we have the monkey putting a force on the rope, and the rope is going to be pushing up while the monkey pushes down. So these are equal opposite forces. And how is this going to change it? Well, when the monkey is climbing up, that is going to be pushing a force down on the rope, and you can see when we separate these from the monkey and the stone and the rope in the system, you can get a general idea what is going to be happening. Now let's focus on the stone. Now the stone now is attached to the rope, but something has changed. The rope on the right side, the tension on the right side is increased because of the force down on the rope and the weight of the monkey. So the tension now is going to be two things: the weight of the monkey plus the force down the rope. And since the tension 1 is equal to the tension 2, now the stone is going to be being pulled up with that tension and pulled up with the force of the monkey plus the force down on the rope, which I'm calling the force of monkey legs. Now, since the masses are the same, we can take a look at the net force, and now the net force up is the force of the monkey legs on the right side. So the stone is going to be moving up. So there's the answer. The stone will be moving up while the monkey moves up. And the monkey's dilemma is solved. So as the monkey climbs, the stone moves up, and the monkey can get its fruit without a fear of dying. Now this picture is a playground across my road. I live in New York. I don't usually get to New York often. I thought it'd be interesting to throw it in. Now, are there other ways to solve this? And yes, there's a simpler way to solve that, and that's the conservation of momentum. Now we know momentum is mass times velocity, and the whole system, the initial momentum of the system is 0, and the momentum is p, so p of monkey plus the p of stone is 0. Now we subtract both sides, so they're actually negatives of each other. So mv monkey equals negative mv stone. The masses cancel, so that means the velocities are negative. They're going to be moving in opposite directions from each other. So if the stone and the monkey both fall, then that's how it's going to be opposite. And if they move towards the pulley, then that's how it's going to be opposite. It's important to remember we're talking about directions from a pulley or pivotal point, not from up and down. So this is a simpler way to think about this problem. Okay, so there's a park across from my road. So going back to it, so the As the answer, as a monkey climbs a rope, the stone will go up. And no, the monkey is not in peril. Here's my house. So thank you very much for listening.